Hello, welcome back. Welcome back. Here we go, electricity 7, resistors in series circuits. Now this is getting progressively more challenging. Have a go at the starter questions. Pause now. And unpause. Here we go. Once again, if you don't know the answers to these, go back to the previous lessons. There is no point moving forward, trying to move forward if you don't understand the previous things. It all builds on top of each other. So this lesson today is quite a difficult lesson. It requires a lot of thought. I think you can do it. I mean, I can do it. I used to hate electricity when I was at school. Okay, I love it now because I've got my head around it and understand it. So I'm not going to talk about these. You can read. Let's move on. Here we go. A word about potential difference. Remember what we are talking about. Voltage tells you about the potential, the energy that can be carried by a current. Potential difference across component tells you about the voltage at one end and the voltage at the other. And in this case, the potential difference of this lamp is 1.5 volts because it's connected to 1.5 volts on one end and 0 at the other. So the difference is 1.5 volts. Okay. When I talk about voltage, I mean potential difference. When I talk about potential difference, I mean voltage. We say the voltage across the component. That's another way of saying the potential difference. Okay. Good. Let's move on. I'll show you a little circuit and do a little bit of talking. Where's my thing gone? Where's my thing gone? Don't want that. Don't want that. I want that. There we go. Here we go. Here's a PHET circuit. Go to that website, muck about with the circuit diagrams. They're really cool. Okay. So here we go. This is a series circuit. One component is after the other, and we have the same current flowing through every point. These little blobs here, these charges represent the current, represent the electrons. Okay. If I click on this battery, we can see it's a 24-volt battery. Okay. So in other words, that battery's potential between one and the other is 24 volts. That's a measure of the sort of energy that it can deliver. Okay. So way to think about this. This battery is providing voltage, and it's providing 24 volts. Okay. What are these lamps doing? These lamps are taking voltage and they are transferring the energy into light. Okay, so the question I would ask is, how many volts is that taking and how many volts is that taking? They're both identical lamps, and I will tell you the answer is they will be taking 12 volts each. So if I measure the voltage across this lamp, you can see it's 12 volts. If I measure the voltage across this lamp, it is 12 volts. They are both identical lamps. And so what is the voltage that both of them are taking? They are both taking 24 volts. Okay. Where is that voltage coming from? It's coming from the battery or the cell. And there we go. That cell there is giving out 24 volts. And one way to think about these sorts of circuits, let's just get rid of this for a second, get rid of that, is that a cell is a voltage giver, and that's all the volts we can have in a circuit. That cell's giving 24 volts that get used up by the components in the circuit. So whatever voltage these things are taking must add up to the voltage that's given. Okay, that's conservation of energy. It's the same thing. Well, it's exactly that thing. Okay, so this is a voltage giver. It's providing the energy. These are the voltage takers. They are transferring that energy. Are we okay with that? Have a think. I do encourage you, go to PHET Colorado. Do just a search for PHET Colorado and it'll come up. It'll come up. Okay. Right. Let's get back onto the thing. Okay. So where are we? There we are. Okay, so let's imagine this. Let's get rid of that thing. I don't like that thing. That's boring. Let's get rid of that. Let's put that there. Okay. Let's imagine this circuit here. Look. Okay. We've got two cells. and we've got them connected to 3 lamps, and these are identical lamps. Okay. And the first question is, what current flows through each lamp? And refer back to the picture because the current leaving here is 0.2 amps. It can't disappear. Current never disappears. So the current through each of them must be 0.2 amps. Here's a question. What is the voltage across each lamp? Have a think. I'm going to tell the answer. If you want to pause and have a think, you can. I'm going to tell you the answer now. Here we go. Let's fucking click it. Click. There we go. Take a moment to look at this. These are the voltage givers, and we've got 2 1.5 volt cells. So what's our total voltage that's been provided to the circuit? It's 3 volts. Okay, does that make sense? We have 3 identical bulbs. If they're identical, they're each taking the same amount of energy, and the total energy that's provided is 3 volts. So it makes sense that each one of these is taking 1 volt, 1 volt, 1 volt, adds up to 3. Okay. Pause, have a think about that. Oh, there's the circuit diagram at the bottom. Okay, so voltage givers, this is providing the voltage, and these are voltage takers. That's the energy going into the circuit, and these are transferring it out of the circuit. And they have to add up. They have to add up. Okay. Ooh, here we go. So I've redrawn that circuit as a circuit symbol in circuit symbols, and there we go. It's exactly the same thing, and this is a note that you might want to write down in your book. So in a series circuit, generally, in a series circuit always, the current is the same around the whole circuit, and the components, these things here, share the potential difference, the voltage of the energy source. Okay, pause that, write those notes down. I'm moving on now. Okay, so resistance in series circuits. Okay, when we put resistances in series circuits, the resistances add up. So for example, here's a cell, it's a 9 volt cell, here's a 5 ohm resistor, and here's a 10 ohm resistor. And here are some questions. So what is the total resistance of that circuit? Here we go, that's very simple, because this is the general rule here, that the total resistance in any circuit is equal to that and that. So what's that going to be? 15 ohms. What is the total voltage supplied by this circuit? What's the energy giver in this circuit? There's only one here. That must be, I can hear you from here, 9 volts. Okay, that's fairly simple. The third question is, we've got to apply a formula. What is the current flowing through this circuit? How much current will be going through this circuit? And we can work that out because we know the total resistance of the circuit, and we know the voltage of the circuit. And so we can use the formula I equals V divided by R, and that's going to be 9 volts. That's the total voltage going into the circuit divided by the total resistance of the circuit, gives us 0.6 amps. Have a think about what we're doing there. And then the last one, it says, what are the voltages V1 and V2? Okay. Now, we know that those voltages must add up to equal 9. But what are the individual voltages? Because look, we have a 5 ohm resistor here and we have a 10 ohm resistor there. So they'll both be taking different amounts of energy. Now, this is where we can use the formula again, because what's our formula for voltage? Can I hear you say V equals IR? Let's have a look. If we look at the 5 ohm resistor, we know the current flowing through it is 0.6 amps. We know the resistance is 5 ohms, and so here we've just used the formula. You see that? And that's 3 volts. I can do the same thing again for the second resistor. I know that the second resistor has 0.6 amps going through it, and it's a 10 ohm resistor. Okay, and that works out to be 6 volts. Now look, if that's 6 volts and that's 3 volts, if we add those together, what does it equal? I can't hear you. It adds up to 9. Did they add up to 9? Yes. And we know we're correct, okay? Because the voltage takers must add up to the voltage givers, okay? We can't get any more energy in or out or whatever, okay? Pause, go back, listen to that again, have a think, okay? Before we move on. And I'm moving on now, but really pause, okay? Now then. Here's something you can try and solve now, okay? Thinking about what we did in that last slide. Here we've got a current flowing through a circuit. We've got 3 lamps. We've got some information about each lamp. And the first question is, what is the total resistance in the circuit? Okay. Pause it, and I'm coming back now. I'm going to tell you. There we go. We can work it out straight away because we know the total voltage being supplied in the circuit is 12 volts. And we know the current that it's being given out. And so we can just use the formula R equals V over I. Okay. What is the voltage across the 12 ohm resistor? We can work that out because we know all right, yeah, I was going to do the sums. It's all right, but I had to take a step back and pause then. Look, here we go. We know the voltage across this is 2. We know the voltage across this is 4. And we know that, add that, must add up to 12. Okay? So can you see? The missing voltage was 6 volts. We could have done it that way. That's the way I was thinking of. We know the current flowing through this resistor is 0.5. We know the resistance is 12 ohms. So we could use V equals IR, and that gets us 6 volts. Okay, same answer, 2 different ways of doing it. So what is the resistance of the middle lamp? Okay, now we know that the resistances have got to add up to 24. We did that from the first question, and we've got 2 of the others, so we could work it out like that and get 4 ohms. Or we could do this. That's the way I would have chosen to do it. I'd have gone straight in for the formula, but that's me. Okay, I could have said that the resistance is the voltage, which was 2, divided by the current, and the current going through all of these bulbs is actually 0.5 amps. Okay, and that gives me 4 ohms. Okay. Before I talk about the other thing, okay, quite a lot there to absorb. Go back, listen to me again, have a think, try and follow the story. Okay, see where these answers have come from, write these down and see how I'm thinking solving this. Then have a go at these questions here. Okay, and we can pause that video there. Then these are quite challenging questions, of course. It's challenging material. So pause that, and here are our answers. I think there are 3 answers, aren't there? Check your answers, go back. If you got it wrong, go back, see if you can solve it. Be resilient, have another go, have another go. If you've really given up, get me on Teams, email me with the exact question, say, sir, and I'll see if I can help you. Okay. So, very easy finishing task. 6 little true or false statements. Pause the video and have a go. And I'm going to solve it now. Bazinga. Did you get them all right? Okay. So once again, a lot to get your head around in this. There's not a lot of slides in this because there's a lot of thinking to be done there about applying V equals IR and about how current is the same in a series circuit. Okay. Good. Enjoy.